Welcome back. So we could list out all the ways of getting four aces, right? Remember the problem? We wanted to come up with the different ways we could draw four aces out of a deck of cards. First, we'll assume order matters, and that's what we're doing right now. And then we'll go back again and look at order not mattering. So first, I could draw some ace, right? And then I could draw one of the three remaining, and then I could draw one of the two remaining, and then, of course, I have one choice left for my fourth draw. And this is the smart way of counting the number of different permutations of drawing all four aces. Now, you'll note this has nothing to do with probability, right? It is insanely unlikely that if you shuffle a deck of cards, emphasis on that you will flip over all four aces in any order. But hey, this is not a probability question right now. We'll deal with probability in the next unit. Right now, we just got to worry about counting what is possible. And so you'll note that first thing you can draw would be one of the four aces. Then what you draw second is one of three, then one of two, then one of one. So in all, we could use the fundamental counting principle and say there are 4 times 3 times 2 times 1 different permutations. Or you could use the formula, right? The permutations formula will get you that as well. And that's the smart way of doing it. This is a lot of writing, a lot of thinking, and you have to be so careful not to miss one. And I only did a fourth of it, right? I only did it for the ace of spades coming up first. I would have to do 3 more tables just like this one to find the 24 count. That's assuming I don't mess up. All right, now for a bit of a thinking question. What if order doesn't matter? How many different ways could you get all 4 aces in a row, assuming order doesn't matter? That's right. There's only one way that can happen, right? If order doesn't matter, then the ways this goes down for your first draw is you draw one ace, some ace, then you draw some other ace, and then some other ace, and then finally the last ace. So if order doesn't matter, then all these distinctions, right? All these distinctions don't matter, and you're left with just doing it. There's only one way for you to do it, and that is to do it. So there's only one combination for order not mattering. And again, you can get that by the formula as long as you're careful. Now, let's get to it. So that is a pretty interesting example, right? Really showcases the difference between order mattering and order not mattering. Broadly speaking, there's always going to be more permutations and combinations. There are times where they're equal. But if one number is bigger than the other, it's going to be the permutations that are bigger. I think they're only equal if you're choosing 0, so like 4 choose 0, or choosing 1, should they be equal. All right, so for those of you who are hoping to be done with cards, I've got great news for you. You will be one day done with cards, but it is not this day. So let's talk a little bit about poker. I'm not going to get into poker theory or which hands are better. I don't really care. But we do need to talk a little bit about it just so we can just get acquainted with it. And also because for those of you working on WebAssign or Pearson even, these online tools love working with cards. So let's talk about full houses. If you're playing a card game, usually poker, and you draw 5 cards, and you have 3 of one of kind and 2 of the other kind, that's a full house. So 3 sevens and 2 kings. That would be a full house. If you had ace, king, ace, queen, ace, queen, ace, that is a full house, right? You can move those cards around. You got 3 aces, 2 queens. And here you have 3 threes and 2 twos, which is my joke there. I'm sorry. And so a full house, that's what it is, basically. And my question to you is, how many different ways can we draw a full house consisting of 3 kings and 2 queens? And that's what we're going to look at in the next video. I will pick it up there. If you want to take the time to figure it out now, by all means do. Pause the series, and see if you can come up with an answer. And we'll see if you're right in the next video. See you then.